I just put it in your copy. All right. So the first thing we are going to look into is the methods of sampling. Now, there's a few methods of sampling. There's a few methods of sampling. So they're called random sampling, stratified sampling, systematic sampling, or self-selected sampling. I think some of them are pretty obvious what they do. So random sampling, obviously there's no reason why you've collected this sample. It is a complete random form of sampling. Self-selected sampling, again, you knew who you were selecting. And it's very specific. Then there's these two, stratified and systematic. So a systematic sampling, I think it also kind of makes sense if you understand the word system. There is a system of the way you are sampling your data. So for example, you might say every fourth iPhone, you would check for quality. Going to be checking, and that would be a systematic form of sampling. All right, it's not random because you're doing it every fourth, and it's not self-selected. So you didn't just decide to go, okay, now I'm going to check the fourth, now I'm going to check the 10th, now I'm going to check the 15th. So you didn't self-select it. It was specifically every fourth. So that one makes sense. Stratified, probably the best way to sample. Is it's a form of sampling, that mimics. It's probably the best way for me to say it. Mimics the population. So what does that mean? That means if I, for example, wanted to work out women like ice cream, right? So I wanted to work out how many women like ice cream, and then from that I wanted to work out, obviously, I don't know, let's say their age, their occupation, and so on. What I do, I can't actually go in and get every single woman there is in Australia and try to ask them, okay, what do you like, what's your age, what's your occupation, and what's your favorite ice cream and whatnot. What I would do is maybe get, let's just say, from Australia's population, there is 10 million women. There's 10 million women, right? Now, from that population, we know that there is, this is going to be complicated, but let's say 20% New South Wales, and for argument's sake, we'll forget of the rest of the states and we'll just say 80% in Victoria. From that 20% in New South Wales, we know that 50% are over 60 years, and 20% are greater than 20 years and less than 60 years, and then 30% are below 20, if you were going to include children. And then let's just, again, for argument's sake, you say the same thing. Now, what I will do with my stratified sampling is, if I was to select 1,000 women, then what I need to do from that 1,000, 20% need to be from New South Wales and 80% have to be from Victoria. Once I've got that, 50% of the 20% in New South Wales have to be greater than 60, 20% have to be greater than 20 and less, the last 30% have to be under 20. So what you're doing is you're pretty much, this word right here, you're mimicking the population. So then what you'll say is, from those 1,000 women, let's just say you found out that 2 women that are greater than 60 years old in New South Wales like vanilla, then you can conclude if 2 out of the 1,000 like greater than 60 New South Wales like vanilla, that means, you know, you work out how many times 1,000 goes into 10 million, and then you can say, okay, that are greater than 60 years old in New South Wales would like vanilla. Does that make sense?
Yes.
Does the
Yeah.
whole idea, yeah, fully?
Yeah.
Like I did not, because that is as easy as I can make stratified sampling sound.
Yeah.
Yeah, even my teacher was struggling to explain it as well, and like he confused me a bit, but I get what you're saying.
Oh, great.
Yeah.
And I smashed it. There you go. Thank you. So look, one more time. The biggest word you want to remember is mimic the population. And then you just got to think about, okay, if I've got a population, in that population, there are certain criteria like New South Wales, Victoria, greater than 60. They might live in Western Sydney, they might live in the eastern suburbs, whatever. And the idea is you work out those percentages. And then if you're going to select 1,000 women, 10,000 women, whatever, from those women, you want to select exactly the same amount of percentages so that when you are going to conclude it for the whole 10 million, you can safely say, because we based it off this and we had the same percentage of people, then we can almost conclude that in the population, this is what should happen. You know, greater than 60, New South Wales would like vanilla at 200,000 people or 2 million people or whatever conclusion you end up coming with. Okay. Cool. All right. Out of the 4: random, stratified, systematic, and self-selected. Any questions? All right, brilliant. Let's have a look at A. The names of the members of a club are arranged in alphabetical order, and every 7th person surveyed. What would that be? Every 7th person. So it sounds like it's going to be a systematic sampling. Make sense?
Yes.
From the passengers on a bus, 1 in 4 women and 1 in 4 men are selected. 1 in 4 women and 1 in 4 men. Now, that's okay. Is it random? Definitely not. Is it stratified? Definitely not. Systematic?
Again? Or
Say it again.
is it systematic again?
And the reason why you're saying systematic is because you're saying every 1 in 4 women, right?
Yeah.
And every 1 in 4 men. The problem with that, it's not. It's 1 in 4 women. It's not every 4th man. I can't say that is systematic. It's going to be self-selected.
Okay. Yeah.
Now, do you think you know why?
Kind of.
So, like, look, this is what's happening, right? Imagine I lined up 7 people. 1,
Yeah.
2, 3, 4, 5, 6, 7, and then let's say pause, and then 1, 2, 3, 4, 5, 6, 7, and then pause. And that's how this is working. So a system is going, okay, not you, not you, not you, not you, not you, not you, but you. Not you, not you, not you, not you, not you, not you, but you. And so on.
Yeah.
When I'm saying 1 in 4 women, it looks like this. So same thing, you're lining up if you want your 5, 6, 7, and then whatever, 4, 5, 6, 7. And what's happening is I'm going, okay, out of you 4, I'm picking one of you. Now, it doesn't matter which one, but I'm picking one of you. So I might pick this one today. Then out of you 4, I'm going to pick you. Out of you 4, I'm going to pick you. Out of you 4, you get the idea. You see how that's not a system?
Yeah.
It's
Because
not
it's like anyone in that 4.
anyone in that 4. Perfect.
Okay, that makes sense.
So it's not really a system, even though there is a system in the case that, I mean, you're going every 4, but in that every 4, you're selecting someone randomly. So it's almost called self-selected. Okay. Bum, 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 bum. 60 people complete a postal survey. That's straight away which one? 60 people complete a postal survey. Anything special about the 60 people?
No, it'd be random.
Random. Imagine I just said, Bianca, you were one of those 60 people that completed the postal survey. Is there a reason why I picked you?
No.
If there's no, the answer is no, then it probably was completely random.
Yeah.
2 students are chosen from every class during period 4 to discover whether they are catching a bus home. So 2 students are chosen from every class. So it's definitely not random. Okay, so now stratified. It doesn't say that it's that it was chosen, like it doesn't say the 2 students were chosen from every class and those classes had even numbers. Like it's not really a stratified way. It's got to mimic the population. I'll try to see if I can find a stratified version. 2 students are chosen from every class during period 4. Which one do you think it is?
I think it's self-selected.
Yeah, it is self-selected again.
Because it's kind of the same as B, because it's not
There's 30 students or 28 students or 12 students. Doesn't really matter. You're picking 2. So every 100th name in a telephone directory is called, well,
that's systematic.
the names of all members are placed in a hat and one name is chosen. One name is chosen. Well, okay. Any idea? Say again?
Random.
Yeah, that's completely random. So again, just imagine you 4. If I put your names and place them in a hat and then I just choose one. It's completely random. There's no reason why. And then here we go. Look, from a group of 120 students, Terry used a stratified sample that 45% were girls and 55% were boys. How many boys were surveyed? Obviously, 120 times 55%. But it's not the one I was trying to do. I mean, that's easy. Question 4. All right, I'll get this out. I'll get it out. We'll probably look at that next week. But that's that. Let's see what happens with these ones. Okay, then you got classification of data. So in that data, you've got the different forms of data that you can have, right? These are different forms of data you can have compared to the other one was just capturing the data. So you can have ordinal, numerical, discrete, categorical, continuous, nominal. Now, I personally don't know this hierarchy or what it's trying to talk about, but I think we can kind of get it out, but I'm not interested in that. What I'm more interested in for you guys to understand are these 4. So I think I already know nominal would be here and ordinal would be there, and then I get it. Numerical, which is obviously, and ordinal would be numbers. Okay, order. Okay. Nominal. Bianca, do you know what nominal is?
Yeah, I have my sheet here from school, and it says it's no natural order in which the categories can be placed. So, like, example could be like hair color or something. Okay,
so no order.
Yeah, no natural order in which they can be placed.
And this one would be order. And then we've got continuous, which is numbers. I get it. And then categorical will be in categories. Then we've got discrete, which is whole numbers only. And then we've got numerical, which is any number.
Yeah.
Okay. So from that, I think it looks like it goes categorical here.
Yeah.
And then from categorical, you would get what is called nominal and ordinal.
Yeah.
And then if it's not categorical, which sort of means if it's not words, it's going to be numerical.
Yeah.
And in numerical, it will be discrete and continuous.
Yeah, I have a similar diagram in front of me now, actually.
Cool.
So,
So yeah, nominal, no order, and Bianca just said like hair color. Ordinal would have order. So what's your I don't know, favorite ice cream? Oh no, you can't say that. You can't. That doesn't have order. What shirt size do you wear? So that would have small, medium, large, extra large. It has order. So it's still a category, still in words, but it has actual order. Do you have another example, Bianca?
for categorical ordinal, we've got medals in an event, so gold, silver, and bronze.
There you go. That's it. So it's just there's order, and it's got to be in words.
Yeah.
Continuous is any number that's not a whole number. So discrete is whole number only.
Yeah, so for discrete, we have like the number of siblings. Obviously, you can't have like
siblings, number of cars, number of tables and chairs, and so on. So whole numbers only. Continuous is anything else. So
yeah, so
what's your height? Yeah, your weight. Measure, I don't know, measure flour for baking, whatever. All right, girls, everything's fine. Everything's sent.
Yeah, all good.
All good. All right. So classify the following as categorical and numerical. I would rather. Is that all? Okay, fine. Categorical, I think you guys know that. We'll do more of these ones. Classify the following as discrete to continuous and nominal ordinal. The height of a plant, that would be continuous. The number of males and females, that would be discrete. The mark scored in a quiz out of 10. Tricky, because it depends if you can get 2.5 or if you can't get 2.5. So very poorly worded. Maybe it should have been the mark scored in the quiz multiple choice out of 10, and then you would have said discrete. And if it wasn't a multiple choice, then it's continuous. So, but I think what they want is a discrete. But that's a tricky one. They shouldn't ask that. The birth mass of elephants, of course, that's going to be continuous. All right, and we go again. Nominal or ordinal. So have that would be nominal. The placings in a race, well, you just told us that one. Ordinal.
Yeah.
And the grades A to E allocated to the quality of work has order.
Yeah.
Easy.
Mm-hmm.
Easy. Then we get bar charts. I think I like to do the sector graphs. They're the harder ones. So I'm just going to jump straight to the sector graph. Before I read it, obviously this is a sector graph here. It's usually broken up into different pie charts. I think you guys have done plenty of this by the time year 8 came along. What's the angle sum of a circle?
360.
So the idea is we're going to be breaking up our circle into fractions of 360 degrees. So let's have a read. Jane's income is 500 per week, and her weekly budget is as follows: rent 100, food 125, other payments 75, entertainment 25, car expenses 75, savings of 100. This information is to be shown on the sector graph. Okay, how do you do it? Well, first you've got to work out what fraction each one is out of 500. Right? So rent. Question 3. Rent is 100 out of 500. Food is 125 out of 500. Bills is 75 out of 500. Entertainment is 25 out of 500. car is 75 out of 500, and savings is 100 out of 500. And what do I do after that?
Would
So
you
now
like?
you know. Yeah.
Would you get like that number that gives you, and then you would have to split it up onto the pie graph?
And how? So like imagine this one gave me 1 on 5. What does that tell you?
That 1/5 of it.
But how do you draw that, right? What's the angle now? You're close.
Times it by 360.
Beautiful, and that's exactly what you've got to do for each one.
Mm-hmm.
So now that you've worked out the fraction, well, you know that's a fraction of 360 degrees.
Yeah.
Right? Simple. It's a fraction of 360 degrees. And that's it. So yes, absolutely. 1/5 times 360. What's that? That's a quarter of 360. What's that? Whatever that is over 360, and so on. Cool. So what angle at the center is used to represent all the information? 360 degrees. What fractions of Jane's weekly income is spent on food? 125 on 500. I said a quarter. What angle would represent food expenses? What angle? Food expenses. So that would be a quarter times 360, which is 90 degrees.
Yeah.
And then what angle represents savings? 1/5 of, so 1/5 times 360, 72 degrees. And then of course, show this information on a sector graph. Yeah, no problem here. 90 degrees is there. That is food. Of course, you'll need compass for this, but anyways, we're just going to give some good estimates. 72 degrees, unless you girls, everyone's okay with this and I don't actually need to do it. There's savings.
Yeah, no, you don't have to do it.
Anyone want me to actually finish this off, or we're okay?
I'm fine.
Fine as well, and you just keep going, and then whatever happens, it should add up to 360, obviously. Hardest bit is just the beginning. You gotta start understanding. If I've got a total amount, and this applies for any topic, not just obviously sector graphs. So bar graphs would work the same way, right? You've got 120 students, and then 60 travel by bus, 30 by car, 20 on this, 10 on this. Show this information on this bar chart. Well, first measure it. Okay, it's let's say 15 centimeters long. Okay, so 60 out of 120 we're by bus. So 60 out of 120 times 15 centimeters. So 7.5 centimeters I have to cover with bus, because half of it is bus, and so on. It's not hard. I know you guys get it, but you got to just remember it as well. Remember that it's actually that simple. Cool. Move. We're doing well. Dot plots, also pretty easy. You've got your score, you've got your tally and frequency. Pretty much the same thing. Frequency is just a number, whereas tally is this. Year 3, right? Complete the frequency distribution table. 1, 2, 3, 4, 5, 4, 5, and then you write the number and so on. How many scores are less than 3? Does that mean you include 3? If I said less than 3, do you include 3?
Oh, you do?
You do?
No.
No, you don't. You don't include 3.
Because it wouldn't it say like including like less than 3 and including 3 in the question, and then it would mean that you did.
Say that again.
Like if it said it in the question, then it would mean that it did include 3.
It would say how many scores are less than or equal to 3.
Yeah.
Yeah, or how many scores are less than 4, then you would include 3. But how many scores are less than 3? That'll be 2, 1, and 0, and then you just got to work out how many frequencies there were for that one.
Yeah.
Draw a dot plot. So imagine, hypothetically, I don't think I need to keep tallying these up, but we're just going to say these were the numbers. Hypothetical. Sorry, someone's just calling me, and I know that that's going to make this slow. I'm just waiting for it to go. Quickly. Okay, it should be good. So draw a Doppler at 1. You've got 1, you've got, that's strange, they didn't put 0 in. No, we'll put 0 in. 0, there was 5, so you're just going to draw 5 dots. 3, 4, 5. 1, you draw 2 dots. 1, 2, 2, you draw 6 dots. 6, and so on. Easy.
Yeah.
What does this dot plot show about the sample survey? I'm sure they meant something else, but in this case, it's pretty random. It's going up, down, up, down, up, down. So it doesn't show anything, but I think what would have happened.
Is that referring to the spread? Or,
yeah, correct.
Yeah.
And that's what I was going to show you.
Okay.
So I think what would have happened is that you would have had probably this. And it looks pretty symmetrical, and that's probably what would have happened. Easy. Stem and leaf. Stem and leaf plots. The way we take these guys on is these numbers at the front are your stem, and then these numbers in the ones column will be your leaves. You got to work out what you're going to start with. You can see that 3 is the lowest number here, so your 30s. So your stem is 3, 4, 5, 6, 7, 8. I can see a 90, so 9. There's no hundreds, and that's it. That's my stem. And then it goes 31, 33, 38, 38. 33, 38, 38. Then I've got 49, and that's it. 50, I've got 51, 55, 56, 57. I just realized I missed the 38. So easy fix. There it is. 51, 55, 6, 7. 60, 62, 62, 62. So 2, 2, 2. We've got a 60. We've got a 68, 67, 68. So 7, 8, 8. 70. I've got 71, 71, 73, 73. 79. So 71, 71, 73, 73, 79. I've got an 82, 82, 82. I missed the 69 again. 82, 82, 82. I missed the 69. Make that into a 9. And 91, 93, 94, 95, 91, 93, 94, 95. Did I finish everything? Yes, yes, yes. Yes, yes. I missed the first one. 53, 53. See how I even double checked? All right, that's how that's done. And then from there you can work out the spread and everything, which is coming up soon. We're going to be talking about that. So complete an ordered back-to-back stem and leaf plot. So if it was a back-to-back one, it works exactly the same way. See? So there's girls here and boys here, and then you just got to go 146, let's say, for girls. And then for 143. So that would be 3, and then 6, and then 9. So 3, 6, 9. Any questions? Boys would be Nothing. There's no 140s. So you don't write nothing. You don't even write 0. Right? Because that would mean 140.
Yeah.
For girls, 150, so 153, 151, 153, 153, and so on. And same thing with the boys. Have a look. Any 150s? Yep, 151 and 158. So 1 and 8. And so on and so on and so on. And that's it. That's how that works. So it's just back to back. Instead of writing 2 of them, which would be annoying, you can just write them side by side. The reason why they do that, because then you can easily compare between the boys and the girls. So the first thing you can just tell is there are no boys that are 140 centimeters, let's say. And then probably would conclude that boys would be taller than the girls. And that's probably something you like to do back-to-back stem leaf plots for, like, you know, height between boys and girls, marks between classes, and so on. Easy. All right. Still done. Then we get what we call grouped data. Now, we don't always want to, you know, separate the data into individual numbers. What we like to do is group them. Like, we're happy to group the weights of men between 72 and 76, because they're all within the same range, and 77 to 81. We're not interested to know how many 72s there were, or how many 73s there were, or 74s there were. So we're happy for them to be in a group. If they are in a group, unfortunately, we can't use 72 to 76. You must use the class center. How do we find the class center? You go 72 plus 76 divided by 2, which is, of course, 74 in this case. Again, you'll just do 77 plus 81, so you're finding the average, literally, which is 79, and so on. 84, 89, 94. Cool? The reason why I'm saying you need to find the class center, because eventually we're going to find our mean, and our mean cannot be any of these numbers. It's got to be this number multiplied by the amount of frequencies you have, which is, let's say, 5. And that gives you the total of people that are in this weight range. 74 times 5 plus 79 times 15 plus 84 times 29, and so on. Does that make sense? Have to find class center. So anytime you guys get given a group of class or a class of scores, just the only thing you need to remember, cannot use these. Must find class center.
Yeah, that's what I did the other day, actually, in maths.
Must.
Yeah.
That's it. That's the only thing you need to remember with that. All right. Cool. Yeah, same thing. So here, they gave you a whole bunch of scores for the number of hours that I've worked, and then it says pretty much break it up into 7 groups. So what you'll see is, I don't know, you might go, okay, all the ones that are from, all the ones that are from 35 to 37 maybe, if that's enough to get to 7 groups. That's 37. Or maybe 35 to 39. Then you'll say that's group 1. Group 2 is from 40 to 44. And it's got to be symmetrical. It's got to be even, by the way. So once you start from going from 35 to 39, if that's 4 people, right, from 35 to 39, that's 4 away. Then it's got to be from 40 to 44, also 4 away. You can't go, okay, I'm going to go 4 away here, and then I'm going to choose all the ones from 40 to 48. That just won't work, because you've got obviously a larger group here. It's got to be even, and I think we understand that. That should be almost common sense. So it's got to be pretty even amongst each one. Your unit's got to be the same. You can't go up 5 here and then go up 20 here. That doesn't make any sense. So you got to group them up into 7 groups. Do I need to do? You'll just have to find your 7 groups. Like maybe you might go 4 away, and then you realize, oh, I don't have 7 groups. You'll go 5 away, and then you find your 7 groups. Whatever. Is that okay?
Yeah.
Let me know if I'm going fast as well. I feel like I am, but it's also because a lot of this is just last year's work. Cumulative frequency tables and graphs. There's a difference between cumulative compared to just frequency, right? Cumulative, you accumulate, oh, serious? No, no. Oh, come on. Doesn't matter. Accumulate, you add up the frequencies. All right, so cumulative frequency works like this. So look at it, 55 to 59, you found the class center, found the class center, found the class center, found the class center. You tallied it, you wrote it up into numbers. Cumulative frequency, your first number is 5. Does anyone know how to find my cumulative frequency? What the next number here would be? You're accumulating, you're adding up your frequencies. Any ideas of what this number should be? Bianca, any idea?
No, I'm not sure.
What if I did this? Does this ring a bell?
Oh, 9.
Yes.
Okay, yeah.
And then?
And then 15.
So the idea was, yeah,
Okay.
literally, you're accumulating your frequencies.
Yeah.
So you start off with 5, and then you just go 5 plus 4, 9. 9 plus 6, 15. 15 plus 7, 22. 22 plus 10, 32. 32 plus 12, 44. 44 plus 6, 50.
Mm-hmm.
And what should happen, your cumulative frequency histogram can never be like this. That would be a histogram, right? Your cumulative frequency histograms will always be increasing, getting larger and larger and larger, because you're adding numbers, frequencies. You're adding your frequencies together, so it's only going to get bigger and bigger. So at 57, your cumulative frequency is 5. At 62, it's 9. At 67, it's 15. And you can see like these numbers are in the middle, right? At 72, it's 22. At 77, it is at 32. At 82, it is at 44. And if you've done it right, if you've done it right, 87's at 50. What should happen is we should hit the 50 mark. And like I said, can you see how it's increasing? And your polygons, with your frequency histograms, they go to the middle. Oh, I always get them mixed up, so let's make sure as well. Frequency histograms and polygons. Let's not risk it. Yeah, they're in the middle. I thought so. So your frequency histograms are in the middle. Your cumulative frequency histograms, your polygons are not in the middle. So they're at the edges. Your frequency histograms go down and they start at 0. These ones don't go down because, of course, it's cumulative, right? So it's only going to get larger and larger. There, that would be your histogram. Sorry, that would be your polygon.
Mm-hmm.
All right. Any questions? So cumulative, you can't forget it. It just means accumulate, add up all your frequencies. Add up your frequencies. Yeah, easy. Okay. Brilliant chart. So this way and this way. Should be easy. And just see what's left so I can show you that. Motor vehicle statistics. Yep, easy. Let's do this one real quick and we'll come back to the previous charts. Table shows the number of people injured in motor accidents in 1 year. Females, males, female drivers, female passengers, female motorcyclists, female pedestrians, female pedal cyclists, male drivers, and you get the idea. What was the total number of males injured? Just add it up. How many pedestrians were injured? You would go this number plus this number. So this looks like the two-way table that we were just doing for probability. So you can start linking that together. What percentage? That's the same as, look. It's a probability. Same. Don't tell yourself, oh, it's different. No, same. Different topic, same thing. Don't isolate your math. You'll make it harder on yourself. Same. So what percentage, what probability of injured males were motorcyclists? Okay, how would I do that? What would be the number that goes on the top? So what would go, I've got a fraction, what number goes on the top?
The males, and then
Sorry?
the total would go underneath.
Yeah, so tell me, so what goes on the top? What number?
Oh, 2011.
Yep, and then how would I work out the bottom? What would it be?
Add the male column.
Add the male column. So
Yeah.
7994 plus 1417 plus so on. Easy. And that would be the same thing for what probability of injured males or motorcyclists. So that would be the probability. Percentage just means times 100. What percentage of injured drivers were females? So again, you would work out the total of injured drivers and how many were females. You add up the female column over the total of injured drivers injured drivers. So from 6595, so it's 6595, actually, I didn't see drivers, 6595 over 6595 plus 7994 times 100.
100.
All right, any questions there?
No.
All right, keep going. Next one. In the previous year, 6,955 female drivers were injured. Find the percentage decrease correct to 2 decimal places. Interesting. Let's see if someone remembers my formula. Percentage increases and decreases. I did give you a formula that I said, please try to remember this. It will help you long term. Anyone remember it? Percentage increase and decrease.
110 or was like 90% or something. I don't know.
Now that is if you were increasing or decreasing an amount, not finding the actual percentage. So this one says find the percentage. The one you're talking about is Bianca buys a shirt and it's 20% discount, what's the new price? Or what's the old price? Then
Oh,
you do what you just said. This one's actually find the percentage.
I'm not sure.
Remember it? What if I write new minus?
Hmm.
New minus. No, still nothing.
New
New,
minus old.
yes,
I mean, I think I
over.
wrote it down somewhere. I'm just trying to find it.
Now that you've said it, new minus old over, you got 50-50.
Mm.
New minus old over old.
Okay, I swear I wrote it somewhere. I just can't find it.
Now write it. Write percentage increase and decrease to find any percentages. New minus old over old. So what's my answer? New 6595 minus 6955 over 6955 times 100. This formula that I've created, it's so powerful that if you get a negative, which you will, in this case, it just means it's actually a decrease. So if some questions didn't say find the percentage decrease or increase, it just said find the percentage and state whether it's an increase and decrease. If you follow the formula,
So if you get a negative, you already know that it's decrease.
it's already a decrease straight away.
That's smart.
So negative 5.18% decrease.
Yeah.
Decrease by 5%. Okay. Any questions?
No.
Anybody? All good?
Yeah.
All right. Let's go. Shows the percentage of annual motor vehicle fatalities where alcohol was a contributing factor across the days of the week. What's the average percentage in total? It's 34. Yeah, I shouldn't be too hard. My car is purchased 42,000, depreciates in value by 15%. Include a table to record its ownership, all determined depreciation over 5 years, the depreciation and percentage of the original value. Okay, question 3. Please start it off. So I'll give you about 5 minutes just to work on that. Okay. Okay. So what's the amount of depreciation here for year one?
I got 6,375.
Yep. And you took it away, you got the depreciated value, brought that over. Again, girls, look, it's exactly like financial math, right? Put in a different topic, but pretty much the same idea. Then, yep, 36125, 15% of that, 54, subtract, you'll get here, and so on and so on. I think we should be able to do that. What was the total amount of depreciation on the car after 5 years? So pretty much whatever whatever this number would be, and then you'll subtract that from 42,000. So just give me an answer for B when you're ready. Do we have an answer yet, or still doing it? All right. 22, 185, 126 minus. Becomes 18. Just let me know if this number's not right, or if you do get it even. You guys still there, or have I lost you girls? What's happening?
No, we're still here. So I was trying to figure out how to get the 15% to work it out.
So you're just doing 15% of all these numbers, right? So the current value is 36,000. It's depreciating by 15%. And then that's that. And then how much would the depreciated value be? This number minus this number.
Yeah, I was just because for year 5 it didn't have because it didn't have any of the numbers. I was like, okay, what's the 15%?
Yeah, no, it's just this times 15%, isn't it? Because that's what you're doing. Like you're losing 15% every year.
Yeah, that makes sense. I'm a bit stupid.
And then what was the total amount of depreciation on the car after 5 years? The total amount of depreciation, like I said, is 42,500 minus this amount, 18,857.471. Which is 23,642 and 53 cents. And the question says, express the depreciation after 5 years as a percentage of the original value of the car. So what goes on top? Depreciation amount, which we've already subtracted. So new minus old, you could have done that as well. You could have done 18, take away 42. It would have given you negative of a negative right now, because you already know, again, it's losing money, depreciated. So 23,000 over the original value, 42,500 times 100%. Any questions? We've become really quiet all of a sudden. I'm not sure you guys are getting it. Are you super confused?
I get it. It's just my thing keeps cutting out. Sometimes it goes quiet for me and I can't hear everything. But I get it.
Okay, good. Cool. All right. Same thing with everybody else, I'm guessing. All right. Weather statistics. Table below shows the mean monthly temperatures for 2 towns over the period of recordings. Draw graphs to represent the mean monthly temperatures for each town. This one, question 2. So these kind of graphs, they're pretty easy to actually read. So, and they work really well when there is like things to do with months or days in a month. So for example, if we've got January here, and then each circle is represented by an increase of 2. So this first one's 2, this one's 4, this one here is 6, and then 8, 10, 12. Simple. So if you were to read January, you would say January's got 9. So mean number of rainy days, there was average of 9 rainy days in January. February would be 10, March would be 12, and so on. So it's pretty easy to actually read. Obviously, what is the mean number of wet days in September? September would be here. You just go, September would be, it's picking it up as a line. September would be there, which is obviously 6. What is the mean number of dry days in March? Okay, so you know that rainy days is 12. How many dry days in March? How would I work that out?
Well, you would just do like 31 minus.
That's it, easy. 31 days in March minus 12 rainy days is 19 dry days. So just be careful. I mean, that's how they can make it harder. Harder. So just be careful with that. Calculate the total average number of wet days throughout the whole year. Oh, come on. Just add them up. Sum everything. And then what is the average number of wet days per month? Of course, what do? You just summed everything divided by per month. 12. The only place you would go wrong is this bit here. Answer to the nearest whole number. Just be careful when you're rounding, and it should be really, really easy. All right. I think we can move on to the next one. Yep, easy. I guess maybe we'll try this. Question 2. What is the annual cost of a 2-person? We'll do question 3, and it looks like we're done. We'll go back to the Pareto charts, and that's it for today. We've got one more topic left. All right, let's see. I don't want to say anything. Let me see if you girls can answer question 2 on your own. So the sector graph shows the percentage of grey water contributed by sources in the average home per person per day. So shower, 75%, washing machine, 16%, so hand basin would be whatever's left, 75 plus 16, 85, 91, so this would be 9%. And then, of course, start answering the questions. And let's see if we can get this out without me saying anything. Okay. What do we get? 3 litres is used in the shower per person per day. How much grey water is produced by the washing machine?
We got 13.44 liters.
And how did you do it?
So first we divided 63 by 3 to get a quarter.
63 by 3 to get a quarter.
We divided, yeah, so because it's 75%, we divided by 3, and we got 21. So,
Yes, and
And then we times by 4 to get 100%. It was 84. And then
right.
16%.
Yeah.
And then we got 13.44.
84 times 16%. But why did you, per person, per day, how much was produced by the washing machine? An average amount per person per day. So what was your logic for dividing this by 3? One more time?
because it was 75%, so, well, it's made up of 3.
But 75% is for shower. What's that got to do with washing machine?
Because we wanted to get 100% of the
Confused.
pool.
Oh my god, I completely missed that. Okay, yeah, I completely missed it. That's why I was confused. Okay, of course. Sorry. Okay, yes. I am losing the plot there. Good eyes. Because I was just doing 63 times 16%. Good job. So 63 litres is used in the shower per person. Right. So 75%. Cool. So then 80% would be what you just said. So 84?
Yeah.
Yeah, 84 litres, and then you'll times that by 16%, which becomes 13.44. Absolutely.
I got the
You know-
same thing. I just did it a different way.
Yeah. What did you do? 63?
But I even found out the hen basin as well, just to get the total. I did divide times. So I did 16% divided by 75% times 63.
Correct. Yeah.
And I
so
did
63
9%
divided by
as well.
75 and then times by 16. Yeah. Same math. Exactly the same way. Cool.
Mhm.
In a 2-person household per day, how much grey water is produced in a 2-person household per day? All right. Why am I so super confused about this? If 63 litres is used in the shower, per day.
I got 168.
Yeah, we got
Well, if 84 litres, sorry, if
That's
63 litres is used in the shower, then you're going to work that out for washing machine and for the hand basin. Yeah, so it's going to be 63 plus 63. I'll just follow what you just said, Bianca. Divided by 63 divided by 75 times by 16%, and then plus 63 divided by 75 times by 9%.
Yeah.
Why don't you just do 8?
What should happen is get the answer. Sorry?
We just did 84 times 2.
Yeah, so did I.
84 times, obviously.
84 was
My
full
math, my math is so bad right now. All right. Oh my God. Right.
I was like,
Yes.
what is he doing?
Yes, you're right. Don't worry. I'm gonna skip this question because I think you guys get better than me. In a four-person household per year, you'll do the same thing, two-person household, times it by two, and then times it by obviously 365
Yeah.
days a year. Oh, all good. Table shows the household water consumption per person per year and the cost of water per kiloliters in Australia. What is the annual cost of water for a person household in New South Wales? Yeah, that's easy stuff. How much money is saved if a family? How much money is saved if a family of four living in Queensland reduces their water consumption by 15%? Obviously, they save 15% of whatever that annual income is. Yeah, and family of four. So you go times it by 4. I think that's easy. If the price of water in Victoria is to increase price of water in Victoria, so that cost increases by 3.4. Increase means multiply by 103.4%, or you didn't do that, you multiply this number by 3.4%, add up obviously, add it up to $2.62. What will be the new annual cost of water for a family of 4, whatever that is, times it by 4, times it by the consumption. Yep, I think that's easy. All right, Pareto charts. Let's finish this off. Bianca, you've done these charts?
No, I have not. Let me check my booklet because it might be coming up. For our next lesson, it's like low quartile.
Okay, that's our next lesson.
Okay.
So our
So
next lesson.
For me, it's got this lesson will be
Next lesson.
Wednesday or Thursday or something.
Okay. Yeah, that's fine. And pretty much once I finish that off, that'll be our last, literally our last topic for standard.
Awesome. Because they're up into like, this is our second booklet because it's apparently a really big.
It is. It's 3 chapters, like I said as well.
Yeah, so we've got
so,
2.
Yeah, cool. So Pareto charts pretty much look like this. It's a type of chart that contains both the bar graph and the line graph. So there it is. Both the bar graph and the line graph. Looks good?
Yeah.
Any issues? Makes sense. It works well because you can read off, like, I don't know. Let me see if I can find a good one. Pareto chart of causes of samples not processed at Masaka Hospital. Machine broken 60%. No, that's a bad one. What does that even mean? No, I'll read that. Doesn't work. Oh yeah. Yep, that looks pretty good to me. Let's open that up. Blah blah blah. Okay, here we go. So looks like this user complaints doesn't work. 78, 79%. Poor tech support, 58%. Low quality, 21%. Overpriced, 12%, and so on and so on and so on. And you can work out which one's the least important to a person. And then the way you would read it on the right-hand side is, I guess, the percentage of, well, it depends, doesn't it? In this case, they've done it as, well, I've got to read the context of this. What do they want to do? Yep, so that's the amount count. Fair enough. Yeah. Yeah. So, okay, well, fair enough. That's just the percentage that it's going up by. So I'll explain that, I think, once we have a look at an example. But that's your cumulative frequency percentage, and that's why it adds up all the way to 100% in this particular case. So that's everybody. That's everybody in the chart. Whereas that would be 40%. 40% of people thought it doesn't work. 40 to 70. So 30% of people said that it's poor tech support. You guys get what I'm saying there? When I'm going from 40, I think it's easier if we do our one, and then we'll see it probably a little bit better. Okay, let's do this. So, a survey of online shoppers recorded the main reason they prefer online shopping. Complete the table: convenience, better price, variety, no crowds, latest trends. Cumulative frequency, you can tell what they've done. They've technically added up the frequency and they've ended up with 80. And then cumulative percentage, we can work that out. That's not too hard. The way it works is, can you see how this number's missing? We don't know how many. Obviously, in this case, is frequency, but you know the total amount of frequencies is 80. So how do I find this number? Obviously, 80 minus 20 minus 12 minus 8 minus 4. This is 36. 80 minus these numbers must give you 36. Why? Because you know cumulative frequency. I start off with 36 and then I just keep adding until I get my whoa, what happened? 68, 76, and then 76 plus 4, I get to 80. So if you know the total is 80, then you can just do 80, take away these, must give you the frequency. Cumulative percentage, how would you work it out? Give me a very good guess. Bianca, what do you think? Cumulative percentage. There's no magic formula, just cumulative percentage.
Would you just add like the certain column and then...
Cumulative frequency is the one you're going to add. Percentage now. You're up to percentage. So percentage usually means write it as a fraction. So what do you think is going to go on the top?
Frequency.
What number?
So 36.
You are right, but I think you're trying to say this frequency. It's cumulative percentage. If it was frequency percentage, you would say 36, this one here. So it's 36 cumulative frequency. 36
okay, yeah.
out of.
So then the one under will be 56 over 20.
No. Cumulative percentage. So 36 out of all of the numbers added up together, which would be 80.
Oh, okay.
20. This one's and then times by 100.
Yeah.
This one's 56 out of 80 times by 100. This is 68 out of 80. Just look at the word again, think about it, cumulative. So I'm going to do these numbers, it's a percentage, so out of the total number, which would be 80. 76 out of 80, and look what happens right at the end. You get 80 out of 80, which is obviously 100%.
Yeah.
So 36 out of 80 times 100 is 45%. So you now know 45% of people wanted convenience.
Mm-hmm.
Now, here you get 70%. What does that mean? Does that mean 70% of people wanted better price? You know that's not true.
Yeah, no.
No, it's not 70% wanted a better price. What is the 70%? Tell me, yeah? If it jumped from 45 to 70, so 25% of people wanted a better price, or the way you could look at it, which is why they do these charts, is 70% of people went for online shopping because of 70% of people went for online shopping because of a better price and convenience.
Okay, yeah, that makes sense. So then the next
Yeah.
one would be because of convenience, better price, and variety.
That's the idea. That's
Okay.
it. And then between them, you can tell what that individual criteria was. So the next one's 85%. That means 15% went for variety,
Yeah.
whereas 85% went for convenience, better price, variety,
hmm
and so on. The last one's 95%. So 10% went for no crowds, and then 5% for the latest trends. So these guys are not interested. Like, when you're trying to do it from a business point of view, you're not really looking at these two. So you now know it's got nothing to do with latest trends and no crowds. All you're trying to market towards are these people. People that are looking for convenience and just a better price. They couldn't care less if it's about the latest trends or not. Or that there's no crowds. Okay. And I think we get how to draw all this up. This is your frequency. So your frequencies are from here. So convenience. Convenience is up to 36. Ugh, sorry, really bad. Better price is 20. Variety was 12. No crowds was 8. And latest trends was 4. Oh, I didn't see they've already done these numbers for us like this. And so on. I think you guys get that. Variety was 12. No crowds was 8. Latest trends was 4. And then go to 85%. Go to 95%. And then latest trends was at 100%, as it's meant to be. Literally. So you can tell a lot of them were here, which is what obviously the bar graph would represent anyways. This tells you how many people in each one. This tells you the percentage increase. The steeper, the more people. The flatter, the less people. Steeper, more people. Flatter, less people. Okay. Any questions?
No.
I'm trying to make this really easy, so in case you guys forget cumulative, you've just got to remember like percentage. Okay, it just usually means something goes on top, something goes on the bottom. Cumulative would mean, okay, get the numbers for cumulative frequency, put them on the top, put them on the bottom. You said frequency percentage for any reason, you'll do frequency numbers over the total number of frequencies. Cool? So whatever it is. Okay, try to see if you can do this one. And then we're done. So try to draw this up, maybe write Monday, Friday, Wednesday, Thursday, Tuesday. Oh, and the reason why it's doing that, why do you think it's doing that? Monday, Friday, Wednesday, Thursday, Tuesday. So that your bar graph will either always be increasing or always will be decreasing. So the numbers they will give you are going to be in order, and if they're not, you've got to make them in order. They're not going to go up, down, otherwise this here won't work. So just keep that in mind. So the reason why they go on Monday, Friday, because Monday was the highest, Friday was second highest, Wednesday was next, followed by Thursday, and then Tuesday was the least. Coffee cup business owner, the number of coffee sold. Okay? All right, go ahead. Give me fill out this table for a Pareto chart. I'll be right back, you guys. All right, I'm back now. Can someone just tell me the numbers for the cumulative percentage of pretty much? Someone just tell me all the answers for the frequency, cumulative frequency, and the cumulative percentage once it's done. All right, what's the answer for the frequency here? What do we get? What do we get here? Confused? Come on, talk to me. Girls? Number for the frequency? Oh, okay. Thanks. Maybe I should start it again. All right, I'll stop the recording.